So in a previous video we talked about permutations, and if you watched the second permutations video, then you kind of got a little bit of a jump start into what combinations are. Now I never said the word combinations in that video, but it turns out we used that idea. So before I get a little bit too far into this, let's take a look at this problem. Radio station's giving away prizes to 3 listeners, so we've got 3 winners. To randomly decide who gets the prize, they're picking them from the last 4 people to call in. So how many different ways can those radio stations choose the 3 winners? So we have 4 possible winners. Let's go ahead and do the long way first and see if we can turn it into a short way. So the first 3 people that they could choose would be 1, 2, and 3. Or they could choose 1, 3, and 4. Or 2, 3, and 4. Or they can choose 1, 2, and 4. Now it turns out these are all of the different possible ways you can do it. But let's take a look here, because technically I could put 2, 1, 3, and I could put 3, 2, 1, and I can start putting all these different things. But they're all going to win the prize. It doesn't matter who gets the first prize, who gets the second, and who gets the third. With permutations, the order mattered. But for combinations, the order doesn't matter. These don't count as unique solutions to it. So a combination, the key to it is that the order doesn't matter. The order, sorry, it's going to bug me if I leave that up there. The order doesn't matter. In permutations, you're dealing with things like a president and a vice president, or first place, second place, third place. But in combinations, it doesn't matter what way we organize them in. If we choose person 1, 2, then 3, or if we choose 3, then 2, then 1. So these are the only 4 solutions. So let's kind of use that idea from the second permutations video to see if we can figure out a short way for this. Let's go ahead and start by finding all the different possible ways. So let's use that permutation. We're going to have 4 people, so 4p3. So I'm going to go ahead and use my calculator, and I'm going to hit that math, and I'm going to go over probability, and I'm going to say that out of 4 people, I'm going to do 3 of those choices, and I get 24 different possibilities. So as a reminder of that equation, it's going to be 4 factorial over 4 minus 3 factorial. But we don't want all 24 of these. We've got duplicates. Just like we did with that permutations. When we looked at that word somewhere, E showed up 3 times. So we had to divide by those. Well, we've got 3 things that are going to show up again. It doesn't matter the order. The first person chosen can be very easily switched with the second person chosen. So we're going to take this, and we have to, for a combination, we're going to end up having to divide it by that. So the answer here is going to be those 3 people that we chose factorial, just like we did with the e's that were extra in the word somewhere. And this ends up being our combination formula. So we would have 4 factorial divided by 4 minus 3 factorial. And now if I put this over 3 factorial, it's going to look really, really nasty. So we're going to go ahead and multiply by the reciprocal. Or in kind of the lower level terms, you can say keep, change, flip. It's just not as fancy. We're mathematicians, we're going to sound fancy here. So multiply by the reciprocal. And here's what that formula is going to be. And if we plug all this into our calculator, or if we go ahead and figure it out since it's kind of small numbers, we'll end up with our answer of 4. We'll have 4 different possibilities for it, which is what we calculated when we did the long way there. So let's see if we can find kind of an easier way of writing this. So what we really did here is we took the number of ways it could be done, divided it by the number of things that we chose, and then the number of things we had minus the number of things we chose factorial. This looks very, very similar to that permutations formula. The only difference here is this r factorial. That's what makes this the combination formula. This is going to be our NCR. So let's go ahead and see if we can apply that to B. So now we've got 30 people going on the trip, and 4 are going to be declared group leaders. So how many different ways can we choose those group leaders? Well, we've got 30 possible things we can choose. We're going to do a combination since it doesn't matter who gets chosen first. It doesn't matter if Billy gets chosen first or Susan gets chosen first, as long as we get those 4 people. So we're going to choose 4 of them. So if we plug it into our calculators, or if we decide to use the equation, so if we use the actual equation here, we've got 30 people. We're choosing 4 of them. We have to make sure to divide by that 30 minus 4 factorial. And we can go ahead and calculate all that out. These are probably going to be much, much bigger numbers, so I would strongly suggest using the calculator. But 27,405 different ways that your teachers could choose those group leaders. So the difference between combinations and permutations is that on a combination, the order does not matter. This is for when it doesn't matter who gets chosen first, second, or third. But for a permutation, it does matter who gets chosen first, second, or third. And that's really the only difference with those combinations. This one little divided by r factorial. That's what makes the difference between order that matters and order that doesn't.